Hi, welcome back for another 6 Caillou challenge called Calculate Hypotenuse of Right-Angled Triangle. To solve this kata, complete the function, calculate hypotenuse, you see over here, which will return the length of the hypotenuse for a right-angled triangle with the other two sides having a length equal to the inputs. More details. The return value should be a number rounded to 3 decimal places, okay? And then you're going to provide an error if either of the inputs are invalid. So they give a few examples here down at the bottom. We see good stuff for the first two, but notice the third example has a negative, and that's how we get an exception. And the final example passes in something called not a number. That's what NaN is, not a number. And we'll look at that. So basically, yeah, we're going to validate the input and then calculate the length of the hypotenuse. If you've had any amount of math, you probably remember Pythagoras' theorem, and that would be useful here for calculating the hypotenuse. They did give a wiki link here, which I assume would show you that same formula. You should know it, so feel free to click that link if you'd like. But basically, you probably remember the formula from school: a squared plus b squared equals c squared, where a and b are legs of a right triangle and c is the side that's opposite of the right angle. I'm going to delete these other comments, but that's basically what we're going to implement in code. Notice here that they also say that both inputs are valid numbers and above 0. I don't think they mentioned that on this side, but even if you didn't know, that would have come up. So we could say, first things first, we'll validate our input, right? We can say if a is less than 0 or b is less than 0. We'll start with these for now. We'll see. We have to check for not a number, but let's just get the idea across. Then we're going to do this thing. We're going to throw an exception. Throw new argument exception, which is a more specific type of exception. Basically, we do this when there's some kind of error. I'm going to bring in the system namespace for that. I think I need that. Well, you know what? Let's let it blow up and tell us it can't find the exception. And then finally, once our input's valid, right, we could go ahead into implementing the function. So how do I implement this, right? I want to sort of isolate it for C. What we're trying to find is the value of C. So this formula, if we were going to manipulate it, imagine taking the square root of both sides, right? That would get us back to C. I'm just going to list the C first. C equals, because the square root of C squared is C. And then it's going to be the square root, which I'll just kind of write like this. Imagine this represents that square root symbol, and everything inside the parentheses is what is being, is what you're using for taking the square root of. So it's that a squared plus b squared, right? That's basically what we're looking for. So let's implement that in code. I'll show you the math class here. To start, I'm going to use the math. Well, I should say the math class, the math library has a lot of these common mathematical functions that you know. ABS would be absolute value. You've got arc cosines, the regular cosine. You can imagine what a lot of these things would do by their name. It's good to know that you have this built in and you can lean on these. Square root, right? That will obviously come up. And we're actually going to round, because remember the instructions told us to round to 3 decimal places. Feel free to examine any of those as you like, but just note for power, raising to a power, they just call it pow. And you take 2 doubles. The first one is the number that you're going to raise, and the second number, y, is the power that you're raising to. And you can see a nice example. The Microsoft Docs usually give you a good example of that in action. I think that's clear. So I'll go back, and what I want to do is calculate the square root of a squared plus b squared. So let's get that a squared plus b squared first. So math pow, that would be a and 2, right? And we know we're going to do that plus the same thing for b, right? A squared plus b squared. Hopefully you can see this little statement I have here represents a squared plus b squared. And now imagine we have to take that whole quantity, right, and take the square root of it following our formula above here. So with the math class, where square root, you can come here, and you just pass the value that you want to take the square root of in as a double precision floating number. It allows you to have a fractional part as opposed to an integer, which is a whole number. So yeah, pretty straightforward, right? You can look at the example if you want, but you're just calling math square root on some value. Fair enough. So let's wrap this whole thing in a call to math square root. So now at this point, I'm taking the square root of a squared plus b squared, which is c, right? This could be the end of it, except for that whole point about us having to round to 3 decimal places. Now I want you to know you can break all of these out into separate statements. You could say, just give it some name. This would give you that square root value, and then we could call math round on this, right? I should probably show you. Also in the math library, you have round. Works pretty much like you think. They're trying to get you to a good example here. Math round. So math round, some value, probably how many decimal places you want it to go. And then this is optional. You can imagine there's different ways to round, right? There's the classic one where if it's 1/2 or higher, you round up, otherwise round down. But there are other rounding strategies. So you would actually find the overload that you're looking for here. This is probably something like this. Yeah, the value you want to round and then how many digits you want it to round to. So we'll try something like that. So we can say we're going to use math round d to 3 digits, right? And I'll end up combining these into one statement. And we could simply return the result. Now, my parameter checking here isn't quite right, but I just kind of want to step you through this so you can see it in action. Okay, the typer namespace name argument exception could not be found. That's what I was trying to tell you before, that there's no class here implementing this, right? So we better bring a reference to that library in so it can be found. So I'm just going to add the system namespace. If you go to the Microsoft Docs and look this up, you will find that. Okay, good. So I passed these simple wave tests right down here, these few, but of course we know that's not the end of it. When we hit attempt, it's going to run us through other things. Okay, so sample test was fine, but you can see they have this group of other tests called error test, and there's another one called random test that we passed. But test failed, parameter 0, 0, it says should cause an argument exception to be thrown. And again, that wasn't, if we go back to the instructions, that wasn't shown in the examples here, but it was, here we go. Inputs should both be numbers that are above 0. Notice I said less than 0, so it wouldn't throw the exception if the arguments were equal to 0. So we can clean that up by simply saying less than or equal to 0. Good. Oops, that was test again. Test should be fine. I'll hit the attempt. We're still not quite there, but we're going to piece this together. And now notice there was a test that passed in some this double NaN, which we're going to talk about. And that should be an exception, right? NaN is not a number. And if you go to the double class in the Microsoft documents, you'll see they have this handy method is NaN is not a number for checking this. This is quite handy for us, right? We just pass in the value that we want to check if it's a number or not. Really simple, right? So let's add that to our input checking as well. So we'll say or double is not a number A, or double is an A, and that second N is capitalized. Make sure you get that right. So we're also checking to make sure that they're both valid numbers as well. So let's try this again. Good. So now you can see we're clear for submission. This is all right. Now all I'm going to do is condense my result a little bit. I can do this all on one line. I kind of break it out step by step so people can see and it doesn't look so intimidating. But this is 6 Caillou, and bear with me if sometimes I over-explain things. I may have just come from an 8 Caillou video and am giving more explanation than maybe is necessary, but you can always speed me up or whatever you got to do. So yeah, hopefully you can see that D here is this. And we can just put that in place of D here. Then we can get rid of this line. And then hopefully you can see result. We're just returning this. So I can simply say return result. They're going to make us run again because we changed the code. And yeah, we're clear to submit. If you want to leave the little bit about how we got our formula, whatever, that's fine. Hopefully you remembered that from junior high or wherever you learned that. If not, not a big deal, but definitely commit it to memory now. I'm going to go ahead and submit like this. And then, as usual, feel free to scan other people's answers to see if there's anything else you can pick up. It looks pretty similar for most people. This was a different way of rounding that we didn't use. They used this convert to double. So if you're not familiar with that, it could be something to look at. Anyway, you know what to do. You know where to find me. If you have questions, hit me up. Otherwise, I appreciate you watching. Thank you as well for the likes and subs. I will see you in another video.